So in this screencast, I will introduce you to temperature and thermometers. Temperature is a measurement of how fast the particles or molecules are making up a substance are moving. The slower the particles are moving, the lower the temperature, and the faster the particles are moving, the higher the temperature. Now, you were introduced to thermometers as a piece of scientific equipment that we will be using. In my classes, I had students look at thermometers when we went over that presentation. And one thing that they noticed that the thermometers both had in common were this red liquid that were in them, or that's in them. The liquid is actually has a red dye added to it to make it easier to see. And they noticed that on our thermometers that we provide for you, the Fahrenheit scale is missing. So we won't be measuring temperatures in Fahrenheit in science. I did include them on this thermometer picture because that's what's most familiar to you. But the way a thermometer works is that when a thermometer is placed into a liquid where the particles are moving fast or the liquid is warm, the liquid inside the thermometer tube heats up and it takes up more space. Because it takes up more space, it will rise up the thermometer tube. The opposite happens when you take a thermometer and place it in a liquid where the particles are moving slowly. The liquid, the red liquid inside the thermometer cools down and it takes up less space and it falls down the tube. I did want you to see some comparisons for different temperatures on the two different scales. Celsius is based on the key points on the Celsius scale are 0 and 100. Water freezes at 0 degrees Celsius, boils at 100 degrees Celsius. Those points on the Fahrenheit scale are a little bit trickier. Water freezes at 32 degrees Fahrenheit and boils at 212. One other key point, and important to mention because you are having your temperatures taken a lot these days. On the Celsius scale, human body temperature, when it's normal, it's 37 degrees Celsius, and on the Fahrenheit scale, it would be 98.6. Now, we've got some thermometers here, and I'm going to read the actual scale. So those key points I did leave on here. And so this thermometer right here, this one, if I were looking at where is this height, that is reading at about 60 degrees Celsius, and that equates to 140 degrees Fahrenheit. This thermometer here, I'm going to look at the height of the red liquid. I'm going to draw in my line again. That is reading at 15 degrees Celsius. Now, how do I know that it's 15? Well, I'm going to come up here and I'm going to look at the scale. Here's 50, here's 60, and there's this one line halfway in between. So when I see that one line halfway in between, I must know that in between here and here is 5 degrees, and in between here and here is 5 degrees. So this is reading at 15. And that equates to, I think that I drew my line over the 60 degrees Fahrenheit. And this last one, I'm going to come up here, I'm going to draw in my line again. See if the scale has changed. The scale is still the same. So here's 55. So there's one line in between the 50 and the 60. So that means that between here and here is 5. And between here and here is 5. So this time, this one is at 80 degrees Celsius. Now I didn't read the Celsius temperature, or sorry, the Fahrenheit temperatures, or I'm not going to write them down because we're not going to use Fahrenheit as a measurement. And I'm learning how to write numbers here with my annotation. Okay, so you're going to be getting some practice with measurement of temperatures in the next chunk of classes.